Hello friends, in this video we will solve a simple problem using Mollier chart. Let us consider the steam at 10 bar pressure passes through a pipe and expands to 0.1 bar in a throttling device. The temperature of steam after expansion is 100 degrees Celsius and we need to find out the state of fluid before expansion using the Mollier chart. So here the properties given at state 1 is the pressure, that is 10 bar. In our truncated Mollier chart, the pressure given is in megapascal. So here I have to convert this pressure into megapascal. So 10 bar is equals to 1 megapascal. And similarly at state 2, that is after expansion, the pressure is 0.1 bar or 0.01 megapascal and the temperature given is 100 degree Celsius. We know that this throttling process is the isenthalpic process and enthalpy will remain constant. Therefore, H1 is equals to H2. Now let us consider this HS diagram or Mollier diagram. Here on this Mollier diagram, we want to mark the state 1 and state 2. But we know that we can mark a state if we know any two properties at a particular state. So here at state 1 we know only pressure, but at state 2 we know the pressure and temperature. So by using this pressure and temperature we can mark the state 2 on this Mollier chart. So here let us consider the constant pressure line of 0.01 megapascal and constant temperature line of 100 degrees Celsius. Where these two lines intersect, that is our point 2. Now we can plot the point 1 if we know any two properties at that particular point. Here we know that enthalpy remains constant. So here on y-axis we have the specific enthalpy. So we have to plot a constant enthalpy line which is passing through this point 2. So let us draw one horizontal line which is the constant enthalpy line which is passing through the point 2. Now we have two properties at state 1. One is the enthalpy and another one is the pressure, that is 1 megapascal. So we can plot the constant pressure lines of 1 megapascal and where these two lines intersect, that is our point 1. Now once you plot or mark a point, then you can find out rest of the properties at a given point. So here at point 1, on x-axis you can find the specific entropy, on y-axis you can find the enthalpy. Here the dryness fraction is also given, so you can find out dryness fraction also. So at this particular point we can find out the enthalpy, entropy and dryness fraction like this. If you see here at point 1, the specific entropy is about 6.38 and the specific enthalpy is about 2690 kilojoule per kg, and the dryness fraction line, which is parallel to this dryness fraction line of 0.95, we have to plot a parallel line to this which is passing through this point 1. So here it comes around 0.96. So we can list out these properties in a table like this. Enthalpy before the expansion is about 2690 kilojoule per kg. Entropy before the expansion is 6.38 kilojoule per kg Kelvin and the dryness fraction is about 0.96. So in this video we have learned the problem solving technique using the Mollier chart. Thank you.